Welcome back to Statistics, Introduction to Statistics. I'm your professor, David Haywood. And in this video, we're going to be talking about measures of center of grouped data. So measures of central tendency when your data has been grouped. In the previous section, section 1.6, we talked about how to calculate measures of central tendency, mean, median, and mode when you have a raw data set. But sometimes we want to be able to make sense out of graphs when we see them, and maybe use a graph to estimate what a mean or a median would be for a data set. And so we're going to practice doing that in this section. We will also talk about the weighted mean and how to calculate a weighted mean, since that is very similar to the way that we compute a mean from grouped data. In fact, the weighted mean might be the single most important statistic that we cover in your life as a student, okay? Because certain things like your grade in a class or your grade point average are calculated as a weighted mean. So without further ado, let's get into measures of center of grouped data. Okay, so here we are. We're going to cover section 1.7 here. And one thing that I'll say right off the bat is, we could really get lost in the weeds pretty easily with this topic. And so we're just going to kind of scratch the surface. The main idea here is that we want to be able to make sense out of graphs when we're looking at them. We would like to be able to calculate measures of center when we're looking at graphs. Of course, if you're looking at a box plot, then things like the median and the mean will already be indicated on the box plot. So that's really easy. So really our main focus is on bar charts and histograms, trying to look at them and make sure that we understand what the mean and median and mode of these things are. So let's start off with a bar chart with a qualitative data set. So for categorical data, this process really isn't too bad. We're asked in this first example to calculate the mode of the data in the graph below. And it's pretty clear from the graph that the mode is back. Okay? So this is a familiar data set by now. We've looked at this location of injury example several times. But yeah, the most frequent injury location was the back injury, and so that's the mode, right? We would just say mode equals back. A common mistake that students will make will be to list the frequency of the mode as the mode itself, but that's not correct. In other words, a lot of times students would want to say, well, the most frequent observation was the back, it happened 12 times, and so mode equals 12. But that's not correct, right? The mode is the back, right? The mode is the back injuries in this example. Now, why didn't I ask you to calculate the mean and the median for this example? So you should maybe reflect on that a little bit. But the reason that I didn't is because this is a categorical data set. You can't compute the mean or the median for this. If you think about what the raw data would look like, it would look like a list of injuries, back, wrist, elbow. There would be 12, in total there would be 12 backs listed, and 2 wrist injuries listed, and 1 elbow injury listed, and 2 hip injuries listed, and so forth, right? It would just be a list of these injury locations, and we can't compute the mean or the median of that, right? It doesn't make sense to say back plus wrist plus back plus elbow plus shoulder plus hip plus back plus hand, and then divide by however many numbers there are, or however many injuries there are, right? We simply cannot calculate the mean or the median. So I would say, well, the data set or the data are categorical. So we cannot compute the mean or the median. Those are not well-defined measures of center on a categorical data set. Okay, so that's pretty straightforward. For numerical data sets, this process is a little more difficult. And one of the main difficulties is trying to keep straight what the categories are and what the counts are. Okay, in other words, what are your categories or classes, and then what are your frequencies? So it's important to try to keep that straight. But if you can do that, then I think we can kind of intuitively figure out what the mean and the median of a numerical data set would be when you're just given a graph. So here we're not given a histogram, but we are given a dot plot, and this would go similarly if we were given a histogram instead. Okay, but this data set is supposed to represent the number of chocolate chips in Quiznos chocolate chip cookies. And okay, so if I were trying to compute the mean of this data set, I could try first of all to reproduce what the raw data would have looked like. Okay, the cookie represented by this dot right here had 23 chocolate chips in it. Okay, so did this cookie, and so did this cookie. And in total there were 11 cookies that had 23 chocolate chips in them. So one way that I could indicate that is if I'm trying to just sort of reproduce what the raw data looked like, is I could say, well, there were 11 cookies with 23 chocolate chips in them. So this would be 23, 23, 23, 11 times. Okay, so there would be 11 cookies with 23 chocolate chips in them. And then after that, this cookie had 24 chocolate chips in it, right? And so did this one, and so did this one. And in total there were 20 cookies that had 24 chocolate chips in them. So that would be, if I'm adding this to my raw data set, there would be 24 of these, or sorry, 20 of these, 20 cookies with 24 chocolate chips. And then finally, this cookie has 25 chocolate chips in it, as does this one, and this one, and this one. So again, if I'm trying to list out what my original raw data set looks like, then I would have some cookies with 25 chocolate chips in them. In total, there would have been 9 of those. Okay, so 9 times. Okay, so then if I'm trying to calculate the mean, let's say, right, the sample mean, x bar, well, it would be 23 plus 23 plus 23 plus 23, 11 times. So in other words, it would just be 23 times 11, okay, plus 24 plus 24 plus 24, 20 times. So in other words, 24 times 20, plus 25 plus 25 plus 25, 9 times. So plus 25 times 9, okay? And then I would need to divide that by the total number of cookies in the sample. Now here I can just note that, well, there were 11 cookies here, plus 20 cookies there, plus 9 cookies there. So it would be 11 plus 20 plus 9. Okay, so we can punch this into our calculator and see what we get. Let's head over to our calculator. Okay, I'm going to give myself a little fraction, and I want to do 23 times 11 plus 24 times 20 plus 25 times 9, and then I want to divide that by 11 plus 20 plus 9. And there we go, we get 23.95. So that's how we would compute a mean from a graph like this. For the median, well, let's see. So again, try to imagine that you have the entire list of your raw data. In total, there would be 11 plus 20 plus 9 values in that list, which comes out to 40 values. Okay, so there would be 40 values in the list. Now the median is the value that's right in the middle of the list. Okay, with 40 values on your list, the middle value is going to be somewhere between position 20 and 21. Okay, because if you get the value that's between position 20 and 21, there will be 20 values below it and 20 values above it. So if you think about your raw data, you can kind of think about, okay, so what value would be between positions 20 and 21? Well, the first 11 values are 23s, and then the next 20 values are 24s. So position 20 and 21 would be somewhere in this list, and they would both be 24s, right? So the median would be 24. And then finally, as far as the mode is concerned, the mode is simple, right? The most frequent number of chocolate chips in any given cookie was 24, right? That was the most frequently observed value. It occurred 20 times in the data set. So the mode was 24. Okay, so that's how we would calculate the mean, median, and mode when we have numerical data not grouped into classes. Okay, so let's take this a step further. Okay, let's say that we do have a numerical data set that's grouped into classes. Okay, the issue here is that we don't know what the actual values are. So looking at this example, we know that there was one observation. By the way, this represents the commute time to work, okay, for a group of employees. We know that there was one employee whose commute time was somewhere between 0 and 5 minutes, but we don't know exactly what that value was. Similarly, we know that there were 2 employees whose commute times were between 10 and 15 minutes, but we're not sure exactly what their commute times were, right? So what we're going to do in these cases is we'll just give our best estimate. And the best estimate would be the center of each of our classes. So since this first class proceeds from 0 to 5, the center of it would be 2.5, right? And the center of this class would be right smack dab between 5 and 10, which would be 7.5. And if you're not sure how I'm getting those numbers, well, you could just take the average, right? 5 plus 10 and then divide by 2, right? 5 plus 10 is 15, and 15 divided by 2 is 7.5, right? So I'm getting this by doing 5 plus 10 divided by 2. If you can do it in your head, that's fine as well. So I'm just doing these in my head. This one would be 12.5, this one would be 17.5, and this one would be 22.5. Okay, so I'm going to use those as my estimates for each of my classes. In other words, I don't know exactly what commute time this person had. It was somewhere between 0 and 5 minutes, but I'm not sure exactly what time it was. But I'll use 2.5 as my estimate. That's my best guess. Similarly, I don't know what the commute time of this person was. It was somewhere between 5 and 10 minutes, so I'm just going to call it 7.5 minutes. Okay, and these two people had a commute time somewhere between 10 and 15 minutes. I'm not sure what exactly they were, so I'm just going to call it 12.5 minutes, and so forth. And then I can reconstruct my data set, right? So I can say my raw data would have looked something like this, maybe not exactly, but it would have been something like, well, there was one individual with a commute time of 2.5 minutes. There was one individual with a commute time of 7.5 minutes. There were two individuals with a commute time of 12.5 minutes. Okay, there were 6 individuals with a commute time of 17.5 minutes. And then there were 5 individuals with a commute time of 22.5 minutes. Okay, and now this is exactly like the previous problem. Okay, if I want the mean of this, I would say it's 2.5 plus 7.5 plus 12.5 times 2, okay, plus 17.5 times 6 plus 22.5 times 5, okay, and I would divide that now by, well, there was one individual whose commute time was 2.5, one individual whose commute time was 7.5, 2 individuals whose commute times were 12.5, 6 individuals whose commute times were 17.5, and 5 individuals whose commute times were 22.5. And then I pop that into my calculator. Let's see what we get. So again, I'm going to give myself a little fraction. We've got 2.5 plus 7.5 plus 12.5 times 2 plus 17.5 times 6 plus 22.5 times 5. And then I'm going to divide that by 1 plus 1 plus 2 plus 6 plus 5. So that's approximately 16.7. minutes, right? 16.7 minutes would be right around here. So we're saying that the mean is right about there, okay? Remember that the geometric interpretation of the mean is that it's the fulcrum, it's the balancing point. So if you imagine trying to balance this histogram, this is where you would have to place the fulcrum to balance it. And that seems about right, okay? That's what our sample mean is. As for the median, well, there are, let's see, 6 plus 5 is 11, plus 2 more is 13, 14, 15. So there are 15 values in this data set. The middle value is going to be in position 8, okay? Because if we choose the 8th value, there will be 7 values below it and 7 values above it, okay? So if I want to figure out, well, what's the data value in the 8th position? Well, I'm at position 1, 2, 3, 4, and then 5, 6, 7, 8, right? I would still be in this list of 17.5s. So my median would be 17.5 minutes. Whoops. Okay. So fairly close in value. So 17.5 is right about here. So I'm saying this is my median. Okay. It's the value that's in the middle if I arrange all of the data values in order from smallest to largest. And then finally, the mode. Oh, we weren't asked for the mode, so we won't do the mode. I mean, it would be kind of hard. We'd say the mode is probably 17.5. That's the value that occurred most frequently. Or maybe another way that we could say it is that, well, the mode is the modal class. The modal class is the class that goes from 15 to 20. Right? That was the class that occurred most frequently. But anyway, so that's that. And I should maybe clarify, in case it wasn't clear before, that these are only approximations. So maybe I should be using little approximation signs. Okay? Because again, I don't know what the actual data were. Okay? I'm just using the class average for each class to estimate what these values would be. So these are my best guesses for the mean and the median, but they're most likely pretty close to the actual mean and median. Okay, so that's all I have to say about calculating measures of center from graphs. But this concept is related to the weighted mean, and let me show you why. Okay, so note that to compute the mean in our previous example, this is the calculation we performed. You probably weren't thinking in terms of those symbols, okay, but that is what we did. We took each frequency and multiplied it by the class average, xi star. Okay, so we took the class average here and we multiplied it by the frequency, 1. Okay, we took the class average here, 7.5, and multiplied it by the frequency, 1. We took the class average here, 12.5, and multiplied it by the frequency, times 2. Okay, we took the class average here, 17.5, and multiplied it by the frequency, 6. Okay, and then we added all of those up. That's what the capital sigma is denoting. So we took each class average, multiplied it by the frequency, and then added up those results. And then we divided that by the sum of the frequencies, right? 1 plus 1 plus 2 plus 6 plus 5. Okay? So this is the formula for how you would compute or how you would estimate the mean from grouped data, like from a histogram. You don't need to memorize that. I think it's much better if you just kind of intuitively are able to look at the graph and kind of figure it out the way that we did. Okay? But that's the formula that if we wanted to come up with a mathematical formula for it, this is the formula that we would come up with. Again, I wouldn't memorize it if I were you. My only reason for putting it down here is to show you that this is exactly the formula that we would use to compute a weighted mean. So let's look at weighted means. Okay. So as I said at the beginning of the lecture, right, for your lives as students, the weighted mean might be the most important topic that we cover in this course, okay? Because your score, your grade in the class, as well as your GPA, those are both going to be weighted means, okay? We use a weighted mean whenever whenever we're trying to find the average of a data set, but not all of the values in the data set are equally weighted. Okay, so a GPA is a good example of this because not all classes that you take have the same number of units. So if you get an A in a 2-unit class, but a C in a 4-unit class, those two classes, they're not going to be weighted the same, right? So we use a weighted mean in that class, or in that case. Let's practice using this formula, okay? So we're going to multiply each observation by its corresponding weight, and then we're going to add those up. And then we're going to add up the weights themselves and divide, and that's how we'll find the weighted average. So I think this will become more clear as we look at an example. Let's take a look. Vanessa just finished her first semester of college. She got a C in her 5-unit biology class, an A in her 3-unit history class, a B in her 3-unit communication class, and a B in her 4-unit math class. What is her grade point average, GPA? In order to complete this problem, we should point out that an A, when we're calculating GPAs, an A is worth 4 points, a B is worth 3 points, a C is worth 2 points, a D is worth 1 point, and an F is worth 0 points. Okay. So let's make a list of her grades, right? In her biology class, it says she got a C, so her grades were, she got a C in her biology class, and that's a 5-unit class. Okay, she got an A in her 3-unit history class, a B in her 3-unit communication class, and a B in her 4-unit math class. Okay, so these units are going to be the weights, right? This course had more units in it, and so this C should be weighted greater than the A, B, and B in her other classes. Now the C earns her 2 points, right? A C is worth 2 points, so she's going to get 2 points for this. She's going to get 4 points for the A and 3 points for the B's. So let's calculate her GPA. Okay, her GPA is going to be the grade times the weight of the class. Okay, and that's going to be for each class. So the grade times the weight plus the grade times the weight plus the grade times the weight. And then we're going to divide by the total number of units that she took, right? The total number of weights, 5 plus 3 plus 3 plus 4. So let's punch that into our calculator and see what we get. So 2 times 5 plus 4 times 3 plus 3 times 3 plus 3 times 4, and we're going to divide that by 5 plus 3 plus 3 plus 4. And there we go, right? That's her grade point average. I think GPAs are usually rounded to 2 decimal places, so we would say a 2.87. Okay? Okay, and so that's how your grade point average is determined. There might be slight differences here. It can be more complicated than this. Like, for example, if maybe some of your classes you can have B minus or C plus or whatever, and so So if those are factored in, then it can be a little bit more complicated. But that's the basic idea. So now you know how your GPA is calculated. If you go in and you see your counselor and you know your counselor tells you what your GPA is, you know where that number is coming from. Let's look at another example. This is a very common scenario. Now, it's interesting because on Canvas you can actually predict what your grade will be if you because you can play around with Canvas and you can enter in certain scores for different things. And yet I still get questions from students all the time about whether or not they can pass the class or whatever. So let's walk through this example and see if we can learn how to figure that out for yourself. Okay? So the scenario is, it's the end of the semester, the only thing you have left to determine your grade is the final exam. Your average grade in each category of the grade book is as follows, or are as follows. Your average grades, I suppose this should say, in each category of the grade book are as follows. So on average, you've got an 87% on the homework, a 72% on the quizzes, a 79% on the tests, and you got a 95% on your project. The only thing you have left to determine your grade is the final exam. But these are the weights for those things. Part A says, if you need at least an 80% overall to get a B, what score would you have to get on the final exam to get a B? Okay. Well, the way we would compute this is we would say, I'm going to multiply my scores by their corresponding weights. Okay? So I'm going to say, if we want to use the formula from the previous page, we would say this, right? So our let's just call it our final grade, right? Our final grade, G for final grade, is going to be I'm just going to drop the percentages, right? It's going to be 15 times 87 plus 15 times 72 plus 40 times 79 plus 10 times 95 plus 20 times, let's just call it F for final grade or final exam. And then we're going to divide that by the sum of the weights. 15 plus 15 plus 40 plus 10 plus 20, which should come out to 100%, right? Now, if we need an 80% overall to get a B, then we need for this to be greater than or equal to 80. Okay. So what we want to do is take this, we want to take this inequality and solve it for F. That may seem like a big challenge, but it's not really. We just need to simplify a little bit. Let's punch some of these things into our calculator so that we can simplify, right? So I want to do 15 times 87 plus 15 times 72 plus 40 times 79 plus 10 times 95. Okay, and then the 20 times F I can't include in the calculation, right? Because there's a variable there that I need to account for. But that's going to be 6,495. In the denominator, 15 plus 15 plus 40 plus 10 plus 20 is 100, as it should be, right? The total weights should add up to 100%. Okay, so I've got 6495 plus 20 times F over 100 needs to be bigger than or equal to 80. And now I need to solve for F. So the first thing I would do then is multiply by 100. So if I multiply both sides of this by 100 so I can clear that fraction, then I have 6495 plus 20 times F needs to be bigger than or equal to I would just add 2 zeros to this, right? 8,000. And now to solve for f, I would subtract 6495. And I have 20f needs to be bigger than or equal to, oh goodness, that would be 1505, right? I better double check on the calculator. 8,000 minus 6495. Okay. And then finally, to solve for f, I would divide by 20. So f would be 1505 divided by 20. And that's 75.25. So there you go. If you get a 75.25% on your final exam, then you will get a B in the class. Okay? If you get at least a 75.25. So that's how that works. Now, so this kind of begs the question: if I can get a B with a 75% on my final, is it possible maybe for me to get an A? And to answer that question, we would do the same thing that we did a second ago. We would want our grade. To get an A, we need at least a 90%, right? So we would want our grade, which we calculated this way a second ago. I'm just going to write down the simplified version. Okay, we need our grade, which is 6495 plus 20f over 100. We would need that to be bigger than or equal to 90. So I can solve this one as well, right? We would need 6495 plus 20f to be bigger than or equal to 9,000. Then we would subtract the 6495 from both sides, just like before. And we would need 20 times f to be at least 2505. Okay. And then we would divide by 20, right? So we would need we would divide by 20. And so we would need 2505 divided by 20. We would need to score at least 125% on the final exam. So the question, is it possible for you to get an A? The answer is no. Because you can't get more than 100%, right, on an exam. Unless your teacher is nice and offers extra credit or something. But even then, you wouldn't get 25% extra credit on your final exam. So no, it's not possible for you to get an A. But you can get a B, right? You just need to score at least a 75.25% on your final exam, and you've got a B. Sometimes students get really confused by this and they think, oh, okay, so I've already passed the class and I don't need to show up for the final. And that would be a bad idea. Let's calculate what your final grade in the class would be if you don't show up for the final exam. Okay? So if you don't show up for the final exam, remember your grade is 6495 plus 20 times f over 100. That's your grade in the class. If you don't show up for the final exam, then you get a 0 for the final exam, right? So it would be 6495 plus 20 times 0 over 100. Or in other words, just 6495 divided by 100. Now you can punch that into your calculator, but dividing by 100 is easy. We just move the decimal 2 times to the left. So this would come out to 64.95% in the class, which is a D. So no, you better show up and take the final exam, right? Otherwise you're going to get a D. and you're going to have to repeat the course. Okay, but the good news is, as long as you get at least a 75.25%, you can get a B in the class. So that's the idea there, and this is how weighted means affect you as a student, right? That's all I have for this section, so I will check in with you next time.